Hi everyone. This is Sid from Hangzhou Lumen Tree, and right behind me, this is our latest IP65 hybrid inverters. Today, we're gonna do some serious testings under heavy loads for our inverters, and I'm gonna record the temperature and noise level, and hopefully there will be a good result.
Here is the hybrid inverter we're about to test today. This is our load simulator, designed by our team to give us a solid baseline for comparison during the test. Before we kick things off, we'll measure the inverter's base temperature and the room's noise level while the inverter is still off. This will serve as our baseline for performance comparison. Most areas on the surface stay well below 30 degrees Celsius. Both the left and right sides of the inverter are also below 30 degrees Celsius, ranging between 23 and 26 degrees. There are 3 floors of manufacturing base below, so it's a bit noisy, around 40 to 45 decibels. Keep that in mind for later. Alright, time to light it up. Simulator on, 3000 watts load. Let's see what this machine is made of. Back in the testing room now. Time to configure a few settings on the inverter before we kick things off. It's currently 14:57 p.m. Keep this time in mind. Alright, the loads are running, so let's get our baseline measurements for temperature and noise before we dive in. Starting with the front area, let's check the temperature, 25 to 29 degrees. Next, we'll move to both sides of the inverter and see what the temperature looks like there. On the left side, it shows 24 to 26 degrees. On the right side, it shows 24 to 26 degrees. And finally, let's check the noise level so we've got everything recorded, around 10 decibels higher, 52 to 53 decibels. 50 minutes later. After 50 minutes, the inverter's been running at 3000 watts under essential load, with an additional 10,000 watts grid power pushing through. It's a bit cloudy today, so we're seeing about 1500 watts coming into the inverter from the solar panels. Now, let's run the temperature and noise level tests again and see how things are holding up. Alright, here's the update. The front area temperature is ranging from 28 to 33 degrees Celsius. The left side is between 27 and 30 degrees Celsius. The right side is sitting around 28 to 29 degrees Celsius. And the overall noise level is hovering between 52 and 53 decibels. As you can see from the comparison, after 50 minutes, the temperatures across all areas have gone up slightly. But surprisingly, the noise level remains almost the same. You know what they say, action speaks louder than words, and these results speak for themselves. Experiment number 2, let's crank the load simulator up to 5000 watts and see how the temperature and noise levels change under heavier loads. I'll do a similar comparison, and we'll see how the results turn out. 60 minutes later. Here's where we're at now. The front area temperature is between 31 and 37 degrees Celsius. The left side's sitting around 28 to 30 degrees Celsius. The right side is between 27 and 30 degrees Celsius. And the overall noise level is somewhere between 53 and 54 decibels. Here's the comparison chart I've put together, showing all the test results. As you can see, this highlights the differences under varying loads. When the load hits 5000 watts and runs for 60 minutes, the results are pretty impressive. The temperature only increases slightly, and what's really surprising is that the noise level stays almost the same.
Okay, so for those of you who are curious about how inverters handle the temperature and noise level so well, I'm not gonna get too technical into it, but here is a quick breakdown on how we design our systems.
Our inverter uses a larger alumni radiator than most other brands in this price range. More metal, more heat dissipation, that's a win in the temperature control game. When we designed the cooling fan, we didn't just throw any fan in there. We did tons of material testing and compared different options to pick up the quietest fan possible. The result? A fan that does its job without waking up the whole neighborhood. Smart, calm, and efficient. That's how we roll, and that's why our inverter stays cooler, lasts longer, and doesn't scream for attention. The fan spinning our inverter isn't just spinning randomly. It's actually pretty smart. It's controlled by three key factors: the internal temperature, the output power, and the current being monitored in real time. Let me give you an example. When the load increases, the internal temperature starts to rise. Our system detects the change immediately, and the algorithm gradually increases the fan speed to help cool things down. Now here's the cool part. Instead of the fan suddenly jumping to full blast, which will create a lot of noise, we design it to speed up and slow down gradually. That way you get effective heat dissipation without the sudden loud noise. It's this kind of thoughtful, precise engineering that makes our inverter perform better overall. Quiet, cool, and consistent. And last but definitely not least, our DSP algorithms. Now, I'm not going to drown you in tech talk, but think of the DSP like a city's traffic system. Our DSP is like the traffic control center, constantly monitoring and adjusting the speed of every vehicle, making sure everything moves smoothly and effectively. In the same way, our inverter reduces energy loss and improves performance.
Let's wrap it up here. Sure, the noise control is important. It makes the overall user experience better. But let's be real here. The true MVP here is the temperature control. As many of you might know, high heat is the #1 enemy of the electrical appliances. If you can control the heat, you are able to have a stable and long-lasting device by your hands. And this is exactly what we've been doing right now. So what are you guys waiting for? Come to Lumen Tree and ask for anyone on our team, and we will be taking care of you. And that's it for today. Take care. See you guys next time. Bye bye.